Good morning. Thank you for attending this part of the webinar. I'm going to discuss the NEUP fiscal year 17 reactor concepts item 2, RC2 topic, and it's radioisotope retention in graphite and graphitic materials. And that also includes the TRISO fuel as well. Please note that we're interested in prismatic designs and as well as pebble bed designs. We're not going to be discussing molten salt fuels with the fuel flowing inside the salt, so please be aware of that. What's our motivation for getting this data and having it done at the universities? Well, we need high-quality fission product retention data to do deterministic source term evaluations and to be able to model accident scenarios and also normal operating conditions where there may be some releases that will be in the coolant or in the system at the start of the transient. Again, the radioisotope transport behavior is needed for predicting the TRISO fuel portion, the matrix that holds the TRISO particles in the compact or pebble, and then the graphite materials. We're interested in high-temperature gas-cooled reactors using helium, the molten salt designs, and again, we'd like to have this for normal irradiation conditions and accident conditions. And I show here a famous pill diagram that shows how radioisotopes go through TRISO kernels, through the matrix, through the graphite, and into the gas, for instance, in a gas-cooled reactor. The diffusion coefficients that we have in the past are not adequate for the modeling that we now see in AGR 1 and 2 test examples. Again, we're focused on molten salt cooled reactors and high temperature gas cooled reactors, not for flowing fuel inside a molten salt coolant. We have different needs for the particles during radiation and PIE transit. And again, we need to know more about how the graphite retains or releases graphite during temperature conditions and system conditions. We have some results already in our conduction cool-down furnace at Oak Ridge, some results from our Idaho National Lab furnace as well as part of the Advanced Gas Reactor Fuel Program. Proposals should include fission product retention and release experiments. Now, we want to have separate effect tests focused on fission product release, transport mechanisms, chemosorption, and desorption and retention. We are interested in iodine, cesium, strontium, europium, ruthenium, and silver, and you can use non-radioactive surrogates at the university. We do not want to have any radiological problems at the universities. We'd like you to determine time and temperature-dependent fission product behavior, diffusion, sorption, retention, transport mechanisms, and we'd like to have this information at higher temperature ranges for the accident scenarios from 1,000 up to 1,800 C. Now, the NEUP call won't support building your own big furnace like we have at Oak Ridge. I give this schematic here to show you what would be involved. However, if you have a furnace at your university or you have a means to test time-dependent conditions in a furnace situation, we would gladly give you information about our furnaces at our laboratories as well. But we need to make sure that we're not just buying furnaces for one-time use. So we're seeking proposals that provide separate effects fission product data for the TRISO fuel matrix of graphite in both gas-cooled reactors and molten salt reactors. Again, you may use surrogate non-radioactive species at your university. We would like you to do the tests on both unirradiated and irradiated materials. Again, we have some specimens from the AGR, the Advanced Gas Reactor TRISO fuel work, and graphite experiments. And follow-on work can be proposed at the NSUF facilities. For instance, our hot cells, also at Oak Ridge, the case microscopy lab, the SEM, TEM, and FIB locations. If you have a hot cell at your university and feel comfortable using radioactive isotopes, okay. The proposals may use the non-radioactive proportions, principally for material experiments. You can demonstrate experiments or test rigs that could be usable in hot cells at one of the labs. If you don't have a hot cell, we're not going to support you building a hot cell. That's way beyond the price range of the NEUP solicitation limits. Again, experiments, we have specimens that may be used again. And using specimens in liquid salt cooled tests with non-radioisotopes could be proposed as well. And we have pictures here of the FIB at the Materials Fuels Complex at Idaho and the SEM, TEM facilities at Case next to the Idaho National Laboratory. We need to have the data retained in a usable form that can meet NRC requirements. So we would like to have it done under an NQA-1 2009 regime. So that means the data collection, data validation experiments have to be compliant with the quality assurance rules. Again, we can't afford to do the test twice. So again, some quality assurance should be specified in your proposal. We can archive data and simulation results under the Idaho National Nuclear Data Management System. And again, we would like to be able to have the data in a retrievable format. If you have questions, you may email me during the appropriate times in the solicitation process, or Dr. Paul Demkowitz, who's a technical POC for the TRISO fuel work. Again, we have specimens with the TRISO fuel in graphitic matrix rings and graphite-only rings that can help support you. We also have the advanced graphite tests, specimens that have been done. Bill Corwin talked about those, so you can get more information. So thank you very much. I'd be glad to answer any questions that you may have about the draft solicitation or any of my slides.
We'll accept questions over the next few minutes. Please submit them to the question box on the GoToWebinar application, and we will ask them to Madeline. Thank you.
I'll ask a question first, and the team can answer it. The NEUPs must be university-led and not laboratory-led. So, of course, universities may team up with laboratory consultants to help out. So that's allowed, but it should be a university-led project.
Will the project have to involve neutron irradiated samples?
That could be proposed if the university wants to do that, but most of the test reactors at universities are low fluence, so that may not necessarily be adequate. But if they have a very good technical proposal where they would like to, for instance, use a sphere or material and irradiate it, that might be fine as long as they get enough fluence on the tests, and they can do this within the 3-year period. Again, This could be done as a benchmark and also used to compare what we have at the laboratories from our graphite and triso work. We won't send archive compacts to universities to be irradiated in trigas, for instance. There's no reason to do that. But we do have samples of graphitic material and matrix material. So if a university wants to irradiate that, that would be fine, as long as it complies within the NEUP boundaries.
Does this work scope support modeling or computer simulations?
That could be done. I would like to warn folks that we have had some first principles ab initio modeling of fission product work done in chemical species done in previous NERI and NEA proposals. So if that work is repeated, we won't really score it highly. The purpose of this is not to just do ab initio modeling or diffusion modeling. We have that capability already. It can support some of it, but it should be done with experimental results. So again, the purpose of this is not to build models. It's to do the experiments. But if you need to do some modeling for the experiment, then that needs to be addressed carefully in your proposal.
How far off are the existing diffusion coefficients?
I'm glad you asked. We have some published papers. We'll also have some papers that will show up in HTR 2016 this year that will also be part of the embedded topical at the ANS meeting. Some of them are off by a factor of 10. We also have had other papers presented in previous high temperature reactor meetings. Paul Demkowitz can help you get access to the currently published papers. And again, we will have presentations at the HTR meeting with the ANS meeting so that you can ask questions during the ANS meeting in time to get your abstracts and preliminary intent applications and then the final NEUP proposals. So hopefully that will help you see how some of these diffusion coefficients and how some of the previous data is not adequate. I hope that answered the question.
Will I be able to access neutron irradiated samples from the AGR experiments at INL?
You can have access to them. Some of them have already been prepared and are available through the AGR team, microscopy team. Dr. Isabella Ben-Moyen has these ready. We also have others under preparation at Oak Ridge, and Dr. Paul Demkowitz can also avail you of those samples. We would prefer that the samples, for instance, could be evaluated, for instance, during a summer time or a specific time during the academic year or during the summer. Transporting radioactive samples to universities can be tricky. But we do have archive material and irradiated samples, especially the graphite.
Thank you, Madeline. It appears that's all the questions we have. We are going to take a lunch break at this point. We will return at 1 p.m. To resume the rest of the webinar presentations. And we'll post a schedule beforehand for you to look at during the lunch period.
And please feel free to contact me or Dr. Paul Demkowitz. But remember, general questions need to also be posted on the NEUP website so that we can have the answer available for all. We cannot give special preferential treatment to particular universities. So please be sure to contact us, and we will also try to make sure that your question appears on the website and answered on the website for all to see. Thank you very much for your attention.